Good morning, evening, afternoon, whenever you guys are watching this. I hope that you've had a great day so far. We're going to talk a little bit about energy production. So just remember that currently, in order to produce energy, we mainly use fossil fuels, things like coal, oil, or natural gas. So previously, let's back up even further. So most of the time when we're talking about energy, we're either talking about electricity, like having lights, or we're talking about transportation. That electricity, therefore, can do a couple of things. It can do lights, it can do heating, it can do cooking, like on an electric stove. So that's typically what we use energy for. And so back in the day, they used biomass or wood as their predominant energy source, and they didn't have electricity, but instead they used the fire for light, they used the fire for heating, and they use the fire to cook their food. Now we see that fossil fuels have taken their place. Fossil fuels are super efficient, and they can be stored. So I can use them. I can take them out of the ground in January. And if I don't use them again until December, they're still there, as compared to things like solar or wind that can't necessarily be stored. And so if we take a look at the graphic that's on the screen, what we can see is that the majority of our energy source from 2017, some of it comes from, about a third comes from natural gas, slightly more than a third comes from petroleum or oil, and then less than that of coal. People are outraged that the coal industry has collapsed, and a lot of them have been blaming this on various political parties. But what we've actually seen is that this is a fair market thing. It's cheaper, easier, and more efficient to get out natural gas. It releases less carbon dioxide. So it was really a capitalistic market that kind of pushed coal aside. If we really look at it, coal employs the same number of people as the fast food chain Arby's. So I don't think anybody is outraged if Arby's were to go away, unless you really, really like their curly fries. So in kind of this way, we've seen that the capitalistic market just kind of pushes coal out of the way because natural gas is better. We use mostly these things to power electricity, which is the form of energy that we use. Just 11% of our energy comes from renewable energy, things like wind, hydroelectric, wood, and solar. And you can see that solar is pretty small at 6%, wind is larger at 21%, and hydroelectricity is the most, and then biomass is in there. And so we're going to talk about those various things in a series of videos. So just so that we're kind of aware, and we already talked about this in class, we've seen the use of our fossil fuels continue to increase. You've seen that coal started to dip. And eventually this graphic is pretty old, 2008. Now natural gas has surpassed coal. If we look at total energy consumption, we see that China and the United States utilize the most. But then when we look at per capita, we see that the developed countries use most. So if we look at total, that's the purple bar. We see China and the United States, and then India. Well, think about how large the population of China and India are, and that makes sense. If you look at per capita, which is the blue bar, then we see that the developed countries of Canada, Australia, and the United States utilize the most. Canada uses more. That would make sense. It's pretty cold in Canada. You're going to need to use electricity in order to heat up your homes. So hopefully that makes sense. Don't forget to look at both labels, both axes when you're checking out graphs. It's important that we're pretty energy efficient, and we talked about a few things you can do in order to improve your energy consumption. So for example, turning down the thermostat in the winter and putting on a sweater, or maybe taking off your socks and shoes and turning up the air, or turning down the air conditioner, making it warmer in your house during the summer. That could be replacing appliances that are inefficient. That could be turning lights off when you're not using them. That could be unplugging appliances we're not using them, or shifting towards more sustainable or better efficient appliances, for example, the CFL light bulbs or LED light bulbs. We also need to talk about the amount of energy that we lose at each step. So, for example, we take out natural gas from the ground. So we remove it from its source. We extract it, we transport it, sometimes on coal. This picture is for coal. Natural gas is usually transported in some type of pipeline. It has to be processed, and then it's sent out, and then it's put into the electricity system before it gets here. And so each of those steps wastes energy. And so the amount that you start with and the amount that you end with are significantly different. You can see the red arrows showing energy loss. And so if we can limit the number of steps, so for example, putting solar panels on the house of the user, if we limit the number of steps that energy has to go through, we're also going to improve efficiency. We want to look at this net energy yield, the amount of energy that you get out from each source. So currently, Fossil fuels had the highest net energy yield, although some solar panels and other things are rapidly catching up with them. Just a general review, we find most of our resources in the Middle East. So you can see that there's large amounts of red, that is petroleum here in the Middle East. There's large amounts of coal in parts of China. You can see it here in parts of the United States, as well as in Russia. And then you can also see natural gas, that's the yellow, here in the Middle East and in parts of the United States. The whole goal of the United States is to be energy self-sufficient. So that may mean that we partner with countries that like us a little bit more, like Canada. It may also mean that we're utilizing natural gas or coal from the United States versus relying on the Middle East. There's just a lot of political things that are involved in that. Uranium, which is green, we see here in parts of the United States, that's going to be really important for nuclear. So just so that we know that fossil fuels are finite in supply, they are going to run out. They are not renewable on the human time scale. So they will form in a couple, hundreds of millions years, but that's not necessarily going to do us any good now. So reserves are deposits that we have that we can extract, or maybe they have stores of them. And what we see here is that there are different productions. So we see curves A, B, and C, and these are how much we have now, how much can we produce, and how long will they last. This has to do with how fast we're using those resources. After a particular point, the resource becomes so hard to extract, like there's so little of it left that it's not really any good. In order to, like, it costs more to get it out of the ground than it would be if we were to sell it. So that's kind of what we call like depletion time. How fast is it going to run out or not become economically viable for us to continue to mine for that? And again, this is just another picture. We see that oil production probably peaked and has started to decline. That just has to do with reserves. So we're trying to shift towards more renewable resources, more natural gas, because we have more options. We have more availability of natural gas than we do of oil, as well as those renewables. So now I've got a little prompt and I'm going to end this video. I hope this was helpful, and stay tuned. I think there's a few more that you're going to need to watch.